Okay, unlike the last video, which was all definitions, you should have already tried all these problems before you start watching the video to see how they're worked out. You should have tried to get the definitions on itself, but I can understand you using the video as well as using a textbook or looking it up and Googling it for those definitions. Alright, in this case, we have 12 problems and they asked us to do three things. They want a coterminal angle that is between 0 and 360 degrees, or between 0 and 2 pi radians for each of these given angles. You can see these first 6 angles are in radians, so we'll find a coterminal between 0 and 2 pi. These last 6 are in degrees, so we'll find a coterminal between 0 and 360. Once we have that, and we have this angle between 0 and 360, or 0 and 2 pi, then we're going to find the reference angle. Notice that we are using two terms from the definitions, right? Then, after we find the reference angle, we're going to take the original angle that's given here, we're going to convert it degrees to radians or radians to degrees. Those are also terms that we had in the definition. So there's 4 of them up there. You need to know what this stuff means. So it takes a little bit. I mean, they're not impossible, but it does take a little bit because a lot of the angles are negative or greater than 360 degrees or 2 pi radians. For example, this one is greater than 2 pi radians. So the first thing I'm going to do is I'm going to try to find an angle between 0 and 2 pi by finding the coterminal angle. You find that by either adding or subtracting 2 pi or multiples of 2 pi. Okay, so I am going to subtract 2 pi, because this is 10 divided by 3, that's 3 1/3. That's bigger than 2 pi. So over here, a little scratch work, I'm going to subtract 2 pi. Now 2 pi is like 2 pi over 1. Your common denominator is 3. So you'd have to multiply top and bottom by 3. This becomes 6, this becomes 3. 10 pi over 3 minus 6 pi over 3 is 4 pi over 3. And that's between 0 and 2 pi, because 4 divided by 3 is 1 1/3. So the very first one, the coterminal angle, I'm just going to abbreviate coterminal angle as CA here. I'm going to say that it is 4 pi over 3. There's my first answer. Now then it says find the reference angle. So since 4 pi over 3 is greater than pi, it says this guy is in the third quadrant. You've got to know that unit circle. If you don't have that memorized, you should be practicing that at the same time as you're studying some of this stuff. So 4 pi over 3 is in the third quadrant. In the third quadrant, I drew it out before. In the third quadrant, if that's your reference angle, this is pi minus my reference angle, pi plus my reference angle, and 2 pi minus my reference angle. So in the third quadrant, this expression, and I got to erase that now, maybe I can squeeze it in. I'm going to take pi plus alpha, and I'm going to set it equal to 4 pi over 3. Alright, because it's a coterminal angle. It's going to have the same reference angle as the original. So I set that equal to 4 pi over 3. I subtract pi from both sides. 4 pi over 3, this would be like 3 pi over 3 would give me pi over 3. And that's my reference angle. So I'll abbreviate that and I'll put down pi over 3. Then it says for you to find, or change this from radians to degrees. Degrees to radians or radians to degrees. So to change radians into degrees, what you do is you take this angle here, which is, I'll squeeze it right in here, 10 pi over 3, and you multiply this by the conversion factor, the ratio here, which is 180 over pi. And you say, well, how do I know it's 180 over pi and not pi over 180? Because if you're converting this into degrees, the pi's have got to cancel. So the pi's got to be in the bottom, 180 over pi. So the pi's do cancel. I can cancel a 3 with the 3 here. That would go in 60 times. So I have 10 times 60. I have 600 degrees. So my answer in degrees is 600 degrees, and all of this is my first problem. So you can see you've got 11 more of these to do, and they're all going to be kind of similar whether they're in degrees or in the radians. So I'll do the next one here. I'm going to subtract 44 pi over 9. I'm going to subtract 2 pi. Now 2 pi is like 2 pi over 1, but my denominator's got to be a 9, so that would be like 18 pi over 9. Now 44 minus 18 is 26 pi over 9, and 9 goes into 26 more than twice, so that's no good. I got to get it between 0 and 2 pi, so do it again. Subtract another 2 pi, which is 18 pi over 9, and I get 8 pi over 9. Now 8 pi over 9 would be in the second quadrant. It's bigger than a half pi, but it's smaller than 1 pi. But first things first, this is my coterminal angle. It is 8 pi over 9. To find the reference angle, since I'm in the second quadrant, which is why I didn't really want to erase this here. In the second quadrant, it's pi minus alpha, so pi minus my reference angle has to be 8 pi over 9. Solve for alpha, so I would subtract pi. I get the opposite of alpha. Now this is like 9 pi over 9. 1 pi is 9 pi over 9. So that would give me negative pi over 9. So take the opposite of both sides and I get pi over 9. That's my reference angle. Pi over 9. Now I need one more thing. I need the degrees. So to find the degrees, go back to the original problem just like I did here. And I'm going to take, let's see if, I'll just put it right here. I don't have much space. And I'm going to multiply this by the same factor, the same ratio of 180 over pi. So the pi's cancel. 9 goes into 9 once, 9 goes into 180 20 times, so it's 44 times 20. That's 880 degrees. And there we go again. There's the next group of answers. Now, again, if you just watch these two and you didn't really get started, stop the video, try the next 4 problems, because they're very similar. Even though this one's got a negative, I'm going to add 2 pi to this to get it to be positive. You still approach it the same way, just like I did here. If you aren't, if after you try these you want to check your answers, come back to this video and start watching again. Pause. Okay, now I'm going to come back to this video here. So this is negative 11 pi over 6. I'm going to find a coterminal by adding 2 pi over 1, multiply top and bottom by 6. So that would be 12 pi over 6, so that would give me pi over 6. Now this is less than a half pi, or less than 90 degrees. This is first quadrant. So pi over 6 is my coterminal angle, but as it turns out, since it's acute, downright adorable, it's also my reference angle, pi over 6. Because the reference angle remembers the acute angle. Now, the only thing I have to figure out is what this is in degrees. So when it's in degrees, I'm going to take this negative 11 pi over 6 times 180 over pi. Now I already know my answer is negative, because this is negative. 6 goes into 6 once, 6 goes into 180 30 times, the pi's cancel. I get negative 11 times 30, I get negative 330 degrees. And there they are. Alright. I'm pressed for time here, let's see. Maybe I should just go ahead and jump to some of the degrees here. Let's try another one. First with radians. So this is less than 0, so I have to add 3, like I did back here. I have to add 2 pi, or 360, 2 pi. So I have negative pi over 12 plus 2 pi, which is like 2 pi over 1. So if I want to get a common denominator here, I'd have to multiply top and bottom by 12. So that'd be 24 pi over 12, which would give me 23 pi over 12, which is just a shade under 2 pi. But that's my coterminal angle. Certainly not my reference angle this time. Oh, 23 pi over 12. And so my reference angle in the fourth quadrant, it's 2 pi minus alpha. You say, well, how do you know it's in the fourth quadrant? Because 23 divided by 12 is not quite 2, but it's more than 1.5, more than 3/2 pi. So it's in the fourth quadrant, so I use this relationship. Look at all this stuff you got to memorize again. And now I'm going to take 2 pi minus my reference angle. That wasn't very good. Kind of connected those. There we go. Is going to equal 23 pi over 12. Subtract 2 pi from both sides. Now 2 pi is like I did up here, is 24 pi over 12. So this is like 24 pi over 12. So 23 pi over 12 minus 20, negative. 23 pi over 12 minus 24 pi over 12 is negative pi over 12. So that means my reference angle Take the opposite of both sides as pi over 12. All right, now I have to have the degrees. So to change this into degrees, I'm going to take the original angle here and I'm going to multiply, I think I got enough space down here to do it this time, times 180 over pi. The pi's cancel, notice it is negative. 12 goes into 12 once, 12 goes into 180 15 times, so it looks like it's going to be negative 15 degrees. That's number 14. Yeah, negative 15 degrees. I think I wrote 150 on my paper, but it's negative 15 degrees. Let me see if I can fix that there. There we go. All right. Next guy up. This is smaller than 0. I'm going to add 2 pi to it. Negative 67 pi over 36. I got to get a coterminal angle between 0 and 2 pi. So if I add 2 pi, which is like 2 pi over 1, do you see my common denominator is 36? I have to multiply top and bottom by 36. That would give me 72 over 36 pi, or 72 pi over 36. Now if I add the numerators, I get 5 pi over 36, positive 5 pi over 36, which is certainly less than a half pi. 536 is much less than a half. So this is acute. So not only is it my coterminal angle, remember CA coterminal angle here is 5 pi over 36, but its reference angle, since it is a first quadrant angle, is also 5 pi over 36. Now to change this to degrees, I'm going to take the original angle, negative 67 pi over 36, and I'm going to multiply it times 180 over pi. I can see it's going to be negative, so in degrees, negative, the pi's cancel, 36 and 180. Look for a number that goes into both. The largest one, it's 36. 36 goes in once, 36 goes in 5 times. So now I have to multiply negative 67 times 5, that'd be negative 300, negative 335. Yep, that's what I got the first time. And there's my set of answers here. Okay, next guy up. 43 pi over 18. 43 pi over 18 is bigger than 2 pi because 43 divided by 18 is 2 and some change. So I'm going to subtract, I got a little extra space up here now, 43 pi over 18, subtract 2 pi, which is like 2 pi over 1. I'd have to multiply top and bottom by 18 to get that to be an 18. So 2 times 18, that would be 36. So 43 pi minus 36 pi, and it's positive there, is 7 pi over 18. Now, a half pi would be 9 pi over 18, because 9 over 18 is a half. So this is also in the first quadrant. I'm getting to like these first quadrant ones because not only is it my coterminal angle, when the coterminal angle is first quadrant, meaning acute, then it's also my reference angle. And that's 7 pi over 18 as well. Now to find this in degrees, and this is my last one that I find in degrees, the other ones I'm going to change to radians, I am going to take 43 pi over 18 and multiply it times 180 over pi. The pi's cancel. 18 goes in 18 once, goes into 180 10 times. 43 times 10 is 430 degrees. And there is the answer to that one. Alright, now we start these last 6 problems here, just kind of doing the same thing, but now where everything's in degrees, so instead of adding 2 pi or subtracting 2 pi, we'll be adding 360 or subtracting 360, which I think you're going to like a little bit better anyway, because there's not the fractions. So this is bigger than 360, so if I take 380 degrees and subtract 360, I get 20 degrees. So not only is that my coterminal angle is 20 degrees, but it's acute, so it's also my reference angle. That's how many in a row like that? 3 in a row? Yeah, 3 in a row. So this is 20 degrees. Now I'm going to convert 380 degrees into radians. So here comes my fraction. I have 380 degrees, which is like 380 degrees over 1, and I'm going to multiply, not like I did back here, where it was 180 over pi, reversed. It's going to be pi over 180. I want the pi as part of the answer, as it turns out. Alright, so now I look for a number that maybe goes into both. 20. 20 goes in 9, goes in 19. So this guy here in radians is 19 pi over 1 times 9, or 9, and there's my answer. All right, this time I'm going to have to add 360. Negative 265 plus 360 degrees is 95 degrees. Now 95, that's in the second quadrant. Let's go back to my drawing back here. Remember with the pi's? Let's change that now. This would be 180. This would be 180. This would be 360. And then I have those relationships in my reference angle. Second quadrant, 180 minus pi, minus alpha, my reference angle, is going to have to equal, where am I at? Oh, down here. 180 degrees minus my reference angle is going to have to equal 95 degrees. Solve for alpha. Alpha is going to be 180 degrees minus 95 degrees, which is 85 degrees. So my coterminal angle is 95 degrees, but my reference angle is 85 degrees. Now I've got to do one more. I've got to change this, like I did before, into radians. So negative 265 degrees over 1 times pi over 180. Now I can see 5 goes into both, but I don't know if 15 does. Let's see, that'd be 11, 13. I don't think 15 does. 5 does. 5 goes into this 36 times. 5 goes into this 53 times. And it's negative. So in degree, or in radians, excuse me, I'm going to have negative 53 pi over 1 times 36 over 36. And there it is. I don't think that reduces anymore. Oh, you can definitely check though if you want to. And there are my answers. This one looks so similar here. Look at this guy. I add 360 degrees to it. And this time I get 75. Well, I like this better because not only is my coterminal angle acute, it means the reference angle is that same angle, 75 degrees, because it's acute. Now I've got to change this into radians. So in the radians, I take negative 285 degrees over 1 times pi over 180. Now I think 15 goes into both of these. Now I know it's negative, because it's negative there. 15 goes into that 12 times. 15 goes into that, there's a negative there, 9 I believe. So it looks like 19 times pi negative, 19 pi all over 12. And there you go. All right, next guy, 808 degrees. Now I can tell that's a lot more than 360. In fact, I know it's a lot more than 2 times 360, which is 720. So I'm just going to cut right to it here. I'm going to take 808, instead of subtracting 360 twice, I'm going to subtract 720 degrees, and I get 88 degrees. Oh, I'm liking this again. Look at this. Not only is my coterminal angle acute, but my reference angle would have to be the same, 88 degrees. Now, what is this in terms of radians? 888 degrees over 1 times pi over 180. I think 4 goes into both. 4 goes into that 45. 4 goes into that 202. And I think that's as far as it goes. So in radians, 202 times pi all over 1 times 45, 202 pi over 45. Okay, I know you're getting tired of these. 2 to go. This one's bigger than 360, so I'll take 475 and I'll subtract 360. And I get 115. Now 115 is in the second quadrant. So although my coterminal angle is 115 degrees between 0 and 360, this is too big. This is obtuse, so it cannot be my reference angle. I have to use the relationship in the second quadrant. It's 180 minus my reference angle. I'm going to set that equal to 115. So that means alpha is equal to 180 minus 115, or 65 degrees. So that's my reference angle. Now, if you don't believe me, draw 115, and you can see that that's going to be the 65. It has to add up to 360, to 180, excuse me. Not helping myself when I keep making silly mistakes. So now I've got to change 475 over 1 into radians by multiplying this by pi over 180. Let's see, it's 12, 16, and 3 doesn't go into it, 5 does. 5 goes in 36. 5 goes into that, what is it, 95? So it looks like 95 pi over 36. 95 pi all over 36, and that would be 475 degrees. Now negative 80 degrees, that's too small. I have to add 360. So if I add 360, I get a coterminal angle of 280 degrees, which is clearly not a reference angle. 280 degrees is in the fourth quadrant. So the relationship is 360 minus my reference angle equals 280. So that means the reference angle is 360 minus 280, which is 80. So 80 degrees would be my reference angle. And one more thing to do, I got to change negative 80 into radians. So negative 80 degrees over 1, I know it's going to be negative, times pi over 180. I can divide, cross cancel 20, goes in 9, goes in 4. Looks like negative 4 pi over 9 radians. And that's those guys. Now, even though there was a little bit of arithmetic, especially with the fractions here, you can see how similar the steps are. All right? You need to be able to do all these. They may not ask you to do all these on the same problem like they did in the review, and they might. But you should be able to do any of these steps. They might just ask you to do one of them, maybe just to convert, or maybe just to find the reference angle. Of course, to find the reference angle, you're going to have to find the coterminal angle that lies in between those values. So make sure that you practice this.